Hello everyone. For this week's tutoring video, I'd like to discuss the mechanics of the inclined plane and diagram the different forces acting upon it, such as friction or gravity. An inclined plane is a sloped surface. In everyday terms, it gets called a ramp that allows you to reduce the force of gravity on an object as you push it up the slope. As you know, normally the weight of an object or the force on it from gravity is the mass times gravity. However, the force of an object pressing down against a sloped surface is lesser than the total weight. And can be derived by breaking down its weight into the x and y components. Or if you remember the basics of vectors, they would be the sine and cosine components. Where the pressing against the surface would be the x component, so it would be magnitude, which is mass times gravity, times cosine theta. And the force of gravity pushing the object back down the slope would be perpendicular, so it would be mass times gravity times sine of theta. Note that as the slope decreases, so does the angle of the slope relative to the ground, until the angle is zero, where the object is directly on the ground. And the weight would be mass times gravity times cosine of zero, and cosine of zero equals 1, so therefore mass times gravity times 1 equals mass times gravity as usual. Although we have successfully shown the forces of weight acting along the slope, both pushing in it and pushing down it, we have not accounted for the force of friction on the slope, which would be against mg times sine of theta. Although for every force of friction, there is two separate types, static and kinetic. For the case of an object rolling down a slope, we would mostly just have to work with the kinetic friction, as most of the time, objects do not sit still on slopes. The force of gravity is too strong for that to happen on most objects. The formula for friction on a slope would be force of friction equals coefficient of friction, or the ratio of the roughnesses of the surface contacting each other, times what is called the normal force, but is just a force equal and opposite to the weight, so you could substitute weight into the equation as well. Because two objects are sliding against each other for friction, the contact areas are always in the same proportion in this case, and so cancel each other out, and we don't have to worry about them when calculating friction on a slope. I will talk more in depth about how to experimentally determine the coefficient of friction and force of friction in the next video. But for now, you can simply look up different tables with different coefficients of friction and simply calculate the weight of the object and then plug and play that times the coefficient of friction you found to get the force of friction. On a sloped surface, force of friction would therefore be coefficient of friction times mass times gravity times cosine of theta because we have shown that the weight of the object that is pressing in against the slope is determined by mass times gravity times cosine of theta. And so the normal force exerted by the slope on the object in return is also that. Note that the coefficient of friction is a weird looking U, which is actually a Greek letter called mu, spelled mu. Theta, for the angle, is also a Greek letter. And you will see many Greek letters in the study of math and physics, because the study of math and physics is much, much older than the English language. And so the formulas found were first determined by the ancient Greeks, and we carry over the characters from the ancient Greek language as it is tradition, and also because math and physics formulas are a universal language. So if we were to alter a character and symbol in one of the formulas, it would have to apply to the entire world, as you would get a different result if you used a different standard. And it wouldn't logically make sense, because math means that the result should be the same for everybody, regardless of where they are. Now that I've shown you how to determine the forces on an inclined plane, I can go over more in-depth measures to experimentally determine the forces and coefficients of friction, which I will do in the next tutorial video.